Welcome back, friends. As we discussed, we'll be moving on with our second video now. Now over here, the question is the same, which should come first, whether it's a CSTR or a PFR. Now the conversion, the change in the question is intermediate conversion is 60 and final conversion is 82. Rest, all the other things are the same. Even the data given is the same. We are just changing the conversions. Again, we are dividing the thing into two parts, as we did it in the last numerical. That is, first part is PFR followed by CSTR and the second part will be CSTR followed by PFR. Here the intermediate conversion is 60, that is the conversion after the first reactor, and the finally converted feed is inserted into the second reactor, wherein the final conversion obtained is 82%. Now how are we modifying the things? Slight change here, because we want to find out what is the final conversion at 0.82. We have not been given the value of 0.82. We have been given the value of 0.8. We have been given the value of 0.85. So we have to find what is the value at 0.82. How we'll do it? Simple enough. Just plot the curve. Okay. For you guys, simplicity is just plot the curve. After plotting the curve, you will have a point on the curve. Okay. For 0.82, just go on up to the curve, that will be the point, and move on up to the y-axis. That point will be 1 by minus RA. Invert that, you will get RA. So definitely you will have what is a new point, and that new point is 0.82. For that you will have RA to be as 920. And invert that, 1 by RA is 920, invert that, you will be getting the value of minus RA. So all these will be on the graph, and we are obtaining value of 0.82 from the graph that you have plotted. So first thing first, we'll have to calculate what is the area under the curve for a PFR. Again, writing the performance equation as we always do, then calculate the area under the curve. As I said last time, area under the curve can be calculated in two ways. One is by dividing the graph into number of trapeziums and then adding that trapezium to get the area under the curve. Second method is just count the number of squares. When you are plotting it on a graph paper, you will be getting number of squares. Count the number of squares, multiply that by the scale on the x-axis and scale on the y-axis. There you will be getting the total area under the curve for a PFR. Okay, so from that we obtain area for a PFR to be around 19.4 liters. Similarly, area of CSTR is nothing but the area of the rectangle, and that you obtain it as 20.24 liters. Going on, we'll add both the values for V1 and V2. We obtain that as 39.64. How do we get it? Again, I'll show you the calculations. First thing, we have to go up to 60%. So we have already added these things. Okay? Go on up to 60% over here. Just take the summation of all these. Summation of all this will be nothing but equivalent to this plus, or we can directly write sum of all these up to 60. Okay, so that it is obtained as 193.96. Let's see whether it's the same. Yes, it's the same. So we get the area V1 to be 19.4 liters. Now for conversion from 0.6 to 0.82, which is the area under the curve for a CSTR, definitely you will obtain this if you just check the graph that we have here. From 0.8 to 0.6, subtract this. After subtracting, you will get the value of 0.22. This is the x-axis value. Similarly, y-axis, one point is 0, the other is 920. So finally you will get 920. So 920 into 0.22, that will be area under the curve for CSTR, or area for a rectangle of CSTR, and the volume obtained is 20.24. Add these two values, you will get a particular value, and that we obtain as 39.64. Similarly, when we go on for CSTR first followed by PFR, we will obtain the graph in such a manner. Now up till 0.6, you will have 400 into 0.6, that will be the area of the CSTR, which is around 24 liters. Again, from 0.6 to 0.82, you'll have to obtain the area under the curve. Here, you don't have 0.82, definitely we have included it. Okay, I'll insert here. I have found it out from the graph, that is 0.82. Your value for R is, okay, you have got the value for 1 by R from the graph itself. Okay, so I'll take the inverse of this. Take the inverse of this. So definitely let me reduce the number of significant digits, so it comes out to be around 0.00109. Okay, next what we do, we have to calculate up to 0.82. Fine. Here now we'll just modify this. Okay, here what will be the case? Again, this time we'll have 800 plus 920. Just check this. 800 plus 920 divided by 2, 0.82 into, sorry, 0.82 minus 0.8. Again, moving this forward. Okay, so I am just using Excel for simplicity because I need not use a calculator, but for you guys, you'll have to calculate each and every point. I am just showing you how you do it. Okay, now you have to take the summation from 0.6 to 0.82. Let me discard this. So how do you take the summation? Summation from 0.6 to 0.82. Okay, done. So it comes to be around 161.55 or 555. Let's check what do we have here. Yes. Okay, fine. So this is the same. So V2 we obtain as 16.16. What do we do next? Add V1, add V2. Finally, we get a particular volume. That is, total volume is 40.16. If you just check 40.16 and over here the volume is 39.64. Definitely, numerical terms 39.64 is lesser compared to 40.16. But that is not a high or significant difference, you can say, right? Whether it is 40.16 or 64, it's approximately 40 liters. So definitely both the combinations can work, either PFR followed by CSTR or a CSTR followed by PFR. So such problems can be tricky. So in this case, either you can say that this arrangement is preferable because PFR comes followed by CSTR has a lower volume and the difference between them is not so high. You can write it this way, or you can say both the arrangements are preferable. Both the answers can be accepted. Okay, so there is no need for confusion. It depends upon your conversion, it depends upon your reaction, it depends upon your initial molar flow rate. So all these factors have a lot to do to decide which arrangement should be coming first and which should be coming later. So for that, definitely I have given you practice problems. And with this, I'm sure it's cleared in your mind that how I have exactly solved the problem. And now it's up to you to solve it and understand it. If there are any further doubts, please let me know. Thank you very much.